This is related rates.
All right, this is related rates. And this is the second video, so go sit down, Olivia, okay? This is the second video where I am finally answering the first question on, I believe that's number 9, that I did not answer before, and that was find the velocity at which the top of the ladder is sliding down the wall. So what we're looking for is this rate right there, which is dh dt. Now the one thing that we know is that dh dt is going to be negative because we have that h is decreasing. We've also just found that this x value is 3.1 meters, right? And we know that the height of the ladder is 5 meters, which is unchanging. So now we need to calculate h. So we have that x squared plus h squared equals 5 squared. I know that x is 3.1. So 3.1 squared is 9.61. So we have that h squared is equal to 25 minus 9.61. So h squared is going to be, what is that? 15.39. And so let's go ahead and find out what that is. So we have on our calculator, we have, I guess I could have done this, 25 minus 3.1 squared. I get 15.39, and then I'm going to take the square root of that. And I get 3.923 something. I'm going to store that as alpha b, just so I can go back and always have that stored in my calculator to go back and do that. So now that I have that, to find dh dt, what I'm going to do is I'm going to try to relate the rates. So right now I have the variables related by x squared plus h squared equals 25. So I'm going to start with that, and then I'm going to relate the rates. So x squared plus h squared equals 25. If I differentiate both sides with respect to t, I'm going to get 2x dx dt plus 2h dh dt equals 0. I could divide both sides by 2 just to get that. I'm going to now replace all of the known values to find the unknown value. I know that x is 3.1 meters, so 3.1 meters times dx dt is 0.8 meters per second, plus the h value is what I just got, so the h was, what's in my calculator, 3.923 something. Times dh dt, which is my unknown, equals 0. So really I have that dh dt is equal to negative 3.1 meters times 0.8 meters per second, all divided by 3.923 meters. And so let me plug that into my calculator, showing you guys. What I'm going to do is negative 3.1 times 0.8, and then I'm going to divide that by alpha b to get negative 0.632, and that's going to be meters per second because the units, those meters, cancel out with one of these, and I'm left with meters per second. So dh dt is equal to negative 0.632. I should say is approximately, right, because I am going to round. So approximately equal to negative 0.632, and that's, again, meters per second. Okay? Now, looking at this, we always ask ourselves if it makes sense based on the sign. Well, dH dt is negative. Again, h right here. H is decreasing as the top of the ladder is sliding down the wall. So yes, dH dt should be negative. Again, h decreasing, dH dt negative, makes sense. So I'm going to just write that down here, negative 0.632 meters per second. And that now answers number 9, what I didn't answer in the first video. Hope that helps.